Evaluating functions. Now, when a function is described by an equation such as f of x equals 3x minus 6, then it provides a way to find the output for a given input. Now, typically in problems, that would be specified by asking you to find f of a specific input. So let's look at a first example. Example 1, say f of x equals x plus 2. So when you see f of x, that means the input is x and the output is obtained by adding x and 2. You have to do x plus 2. Now, the problem would have to specify what input you're trying to find the output. So it will be specified something like this: find f of 3. In that case, you write f of 3 equals that input 3 plus 2. And 3 plus 2 is 5, so that's your answer. Now let's look at one other example where this time the operation is not going to be addition but maybe multiplication. So I'm going to say f of x equals 3x. And then the question might be find f of 5. Now notice, if you don't see any operation between 3 and x, then it's not addition. You're not adding the 3 and x. It's multiplication. You got to multiply 3 with x. So the equation describing the function is f of x equals 3x, and the question is to find f of 5. So for an input of 5, you got to multiply 3 with the input, which is 5 in this case, and 3 times 5 is 15. So that's your answer. Now, these two examples, examples 1 and 2, were quite simple. They only had one operation. It was addition here. It was multiplication in example 2. Now, let's look at one example where you have more than one operation. So, in example 3, I'm going to say f of x equals 7 minus 2x. So notice, this example has two operations, minus and also multiplication. So subtraction and multiplication. And then the question could be find f of 3. Or yeah, let's take f of 3. So how do you go about that? Again, just like examples 1 and 2, you're going to replace x with the input specified in the problem, in this case 3, and you're going to write 7 minus 2, and remember 2x means 2 times x, so it's 2 times 3. Now when you have more than one operation, in this case you have subtraction and multiplication, you got to use the order of operations. So in order of operations, you learn that all of the multiplications and divisions should be done before you do any additions or subtractions. So I'm going to do this problem in 2 steps because it has 2 operations. In the first step, I'm going to do just multiplication, which means I'm going to copy the 7 minus and only do the multiplication, 2 times 3. 2 times 3 is 6. So once I carry out that multiplication, now I'm left with only one operation, 7 minus 6. That answer is 1. Now, I'm going to write down one more example, and in this, via this example, I'm going to tell you what exactly you could do in any given problem to avoid mistakes. So if you're given a function like, say, x squared minus 7x plus 3, and say the question is find f of 2. Now, what my recommendation would be is to copy the function. So f of 2. So copy everything except the x part. X is the input. So wherever you see x, just replace it with a pair of parentheses. Just leave some gap inside the parentheses and copy the rest of the formula. So think of that equation as a formula. So x square means parentheses square minus 7, and then you see x again. So wherever you see x, you want to have a parentheses plus and then followed by 3. Now, the question is what goes inside the parentheses? Remember, x is the input. For this particular problem, it's asking you to find f of 2. So the input is 2. So that's what we want inside the parentheses. Now, some of you might say, why do I need parentheses? Now, here is what I'm going to tell you. Parentheses are going to keep things a little bit manageable, especially when the function is complicated and if the input has its own negative sign. It's easy to lose track of what operation must be done. So having parentheses is going to avoid a lot of mistakes. So that's my recommendation. So I'm going to use parentheses wherever there is an x. Now, so this problem has many different operations. Notice there is actually an exponent, there is a subtraction, there is a multiplication, there is an addition. So it has a whole bunch of operations, and the order of operations tell me to do the exponents first, and then multiplications, and then additions and subtractions. So it's better to take it slowly, do one step at a time. So in the first step, I'm going to just do the exponent, 2 square. 2 to the power 2 means 2 times 2, which is 4. And I'm not going to touch anything else. So I'm simply going to copy the rest of the expression. So I'm done with exponent. Now I see that there is a multiplication which must be done prior to additions and subtractions. So in this step, I'm going to copy the rest of it and just perform the multiplication. 7 times 2 is 14, and I'm copying everything. Now I have subtraction and addition. Now subtractions and additions have the same priority. So when you see both subtractions and addition in an expression, you just want to go from left to right. So I would do 4 minus 14, which is negative 10, and then add 3 to that. So negative 10 plus 3 is negative 7. Now I could have split that into one other step, but there is no danger in just doing both subtraction and addition in a single step. Now, so one comment. Notice, let's go back to example 3. If I had done the subtraction first, if I had done 7 minus 2 first, I would get 5. And then if I performed the multiplication 5 times 3, I would get a totally different answer, which would be incorrect because it did not follow the order of operations. So I think the biggest challenge in evaluating functions is to use the order of operations appropriately. And one thing you could do to make things easy is to use parentheses for x. Now let's work out one more example, example 5, and this time let's make it a little bit more complicated. F of x equals negative x cubed plus 2x square minus 3x plus 4 and say find f of negative 1. Now this is where you're going to notice that using parentheses is going to be extremely helpful. So it's not f of x. I should be finding f of negative 1. So f of negative 1 is, so I'm going to copy the entire formula except for the x part. So x should be replaced with parentheses, then there's a cube followed by a plus, 2 followed by x square minus 3 and then x, so have parentheses for that, plus 4. Now write your input within the parentheses. Now it has several operations. The definition itself was long, the input is negative. It's going to make it really cumbersome, and it's very easy to make a mistake, especially on multiple choice tests. There would be a choice where it's easy to pick a wrong one. You make a simple mistake and then you end up with an answer, and you happen to see that in the choices. So let's be extremely careful. Let's follow the order of operations. The order of operations say do parentheses first, but in the parentheses there's nothing to be done. It's negative 1, so there's no operation inside the parentheses, and the next priority goes to exponents. So in the first step, just do the exponents and keep everything else as it is. So copy the negative. Now what is negative 1 cubed? Negative 1 cubed means you're multiplying negative 1 by itself 3 times. Negative 1 times negative 1 times negative 1. And that answer is again negative 1. Alright, then copy the plus 2. Remember this step, we are only performing exponents. And now negative 1 square is positive 1, because negative 1 times negative 1 is positive 1. Negative times negative is positive. And just like we have said before, in this step we are only going to perform exponents. Now the next priority is for multiplications. So let's go ahead and multiply. Negative times negative 1 is positive 1. So we will do that. Then 2 times 1 is a 2. So plus 2. And then I want to see this as negative 3 times negative 1. If I see negative in front of 3, I can say I'm multiplying negative 3 with negative 1. So that gives me positive 3 and then plus 4. So now what I have is 1 plus 2 plus 3 plus 4. I can add that. And that gives me 10. So I think these examples should help you evaluate functions. And I have some practice problems that I have written earlier, which I'm going to put them here. And also, the answers to the practice problems will be in the video description below. All right. Be sure to practice them, and I'll see you in the next video. Thank you.